students, and welcome back. In this session, we will be completely studying about the next property of rational numbers, that is associative property of rational numbers. Till now, when I look at rational numbers and the properties of rational numbers, we have studied closure property, we have studied commutative property, and the third property is nothing but associative property. Alright, so when I look at properties, I have to check for all the four basic operations. First, it is for addition, next subtraction, multiplication and division. Alright, similarly, even for this case also, I will first see if my associative property is valid for addition, subtraction, multiplication and division. Alright, now when I'm talking about associative property, what do you mean by associative property? When I say associative, we are associating things. Is one set of things same as the other set of things? Are they associated same or are they associated in a different way? Let us check in detail about associative property in this class. Alright, so first, associative property is nothing but, let us take first we will see if associative property is valid for integers. Then we will check if associative property is valid for rational numbers. Alright, so first when I see if my associative property is valid for integers, alright, what are integers? Integers are nothing but they are the numbers which are positive, negative and including 0, right? So minus 2 is an integer, plus 3 is an integer, right? All these are integers. Now, in my associative property, associative property of addition states that let A, B, C be any three integers, then A plus B plus C is equal to A plus B plus C. Okay? Now, easy way I tell you. Let any three attributes you take. Okay, I have taken A, B and C. That doesn't mean you can't take U, V, W or X, Y, Z. You can take. Okay, we have just defined it in terms of A, B and C. Alright, so first we take any three integers. Okay, I'll just take them as alphabets. I have taken A, B and C. Okay, what I did, I put a plus sign between them because I am dealing with addition. A plus B plus C. This is equal to, again same thing, A plus B plus C. Alright, now what I do is, for the first two alphabets, that is A and B, I put a bracket. Okay, here what I do, I leave the first letter and I put the bracket for my second and third letter. Okay, so it becomes A plus B plus C is equal to A plus B plus C. Yes, so this is called as associative property of addition. Easy, right? This, my left hand side should be equal to my right hand side. Then I can say that my associative property of addition is valid. Now when I am talking about associative property, I will take any three integers, okay, because I am getting four integers, right? I can take integers, let my A be equal to minus 1 or something, let B be equal to plus 2 and let C be equal to what? Plus 3, for instance, okay? Now according to associative property of addition, what does associative property of addition state? Associative property of addition is nothing but A plus B plus C is equal to A plus B plus C. Okay? See, whenever there are brackets, you have to give a pause. Alright. Now see how I am telling it. A plus B plus C is equal to A plus B plus C. Clear? So this is called as associative property of addition. Alright. So A plus B plus C. What is my A? A is minus 1. So minus 1 plus 2. Okay, I put a bracket plus, what is C? Plus 3. So plus 3 is equal to A. A is what? Minus 1, right? So I will put, instead of A, I put minus 1. plus as it is in the bracket. What is B? B is nothing but plus 2. So plus 2 and what is C? Plus 3. Plus 3. Clear? So is equal to. What is minus 1 plus 2? Minus 1 plus 2 is nothing but plus 1. Correct? Plus 1 plus 3 as it is. Why am I solving first brackets? Because I am following the law of BODMAS. Brackets of, what is that? Division, multiplication, addition and subtraction, right? So when I am following the rule of BODMAS, first I will solve my brackets. Now what are my brackets? Minus 1 and plus 2 are in the bracket. So first I will solve the bracket. So minus 1 plus 3. Okay. So minus 1 plus 2 is nothing but what? Plus 1 plus 3 as it is equal to plus 1 plus 3 is nothing but plus 4. Correct? So this I have got as LHS. My left hand side is nothing but plus 4 is equal to. Now minus 1 keep as it is. Okay. Plus what is plus 2 plus 3? Plus 2 plus 3 is nothing but what? Addition plus 5. So plus 5. Clear? Now what I will do is equal to minus 1 plus 5 is how much, children? Minus 1 plus 5. Plus and minuses, I have to subtract and put the greater number side. So, I have subtracted 5 minus 1. 5 minus 1 is what? 4. 4. And what is my greater number? 5 is my greater number. It has a positive sign. So, my answer is plus 4. Clear? So, right hand side as well, I have got what? Plus 4. So my left hand side is same as my right hand side. So my associative property of addition is valid. Clear? Very easy, right? Yes, it is. Okay, so it's very easy. Associative property of addition formula is A plus B plus C is equal to A plus B plus C. So this is valid. Why? Because my left hand side is same as my right hand side. So therefore, this associative property of addition is valid. Now let me see for one more example. Okay, now here I have kept, let A, B and C be any three integers, then A plus B plus C is equal to A plus B plus C. Correct? So this is what? This is the formula for associative property of addition. Now, let A be equal to 2, B is nothing but minus 3, C is nothing but plus 5. So, according to this, A, what is A? 2 plus, open the bracket, B is what? Minus 3 plus as it is, C is what? Plus 5 is equal to, what is A? A is 2 plus as it is, what is B? B is minus 3 plus into minus is minus 3, correct? Now, close the bracket plus, what is C? C is 5 plus 5, okay? So, 2 as it is. First I have to solve my bracket. Why bracket? Because according to the BODMAS, whenever I have brackets, I have to solve my brackets first. Clear? Alright. So, first I keep 2 as it is, I keep plus as it is, solve my bracket. Inside the bracket I have minus 3 and plus 5. So plus and minuses, again minus, subtract and put the greater number sign. So therefore, subtract 5 from 3. How much will you get? 2. 5 minus 3 is 2. And why am I writing plus 2? Because my greater number is 5 and 5 has positive sign. 3 is smaller number with a negative sign. But 5 is a greater number with a positive sign. Right? So I have written 2 as it is plus 2 is equal to 2 minus 3 is what? 2 minus 3 is minus 1. Why? Because plus 2 and minus 3. Plus and minuses, subtract and put the greater number sign. So therefore, plus 2 minus 3 is nothing but minus 1 plus 5 as it is equal to 2 plus 2, 4 is equal to minus 1 plus 5. What is minus and plus? Subtract and put the greater number sign. So what is 5 minus 1? 5 minus 1 is 4. So 4, and which is the greater number? 1 is the greater number or 5? Yes, definitely it is 5. So therefore 5 has a positive sign. So my answer will also have a positive sign. Now when I look at this, LHS is equal to RHS. That is, my left hand side is same as my right hand side. So therefore, associative property of addition is valid. Clear? Yes, children. Now we will be studying completely about associative property for subtraction. Okay. Now, when I talk about associative property for subtraction, we know for addition the formula is A plus B plus C is equal to A plus B plus C. Correct? Where I put the brackets for second and third, and here I put the brackets for first and second. Right? So first A you leave as it is, for the last two I put the brackets, is equal to last you leave as it is, first two I put the brackets. So this was what associative property for addition. Now same formula, only the signs will change. Instead of addition you will write subtraction. Clear? Alright. So my associative property of subtraction for integers. See children, I have not yet come to rational numbers. I am still talking of integers. Okay. So let A, B and C be any three integers. Then A minus B minus C is equal to A minus B minus C. Alright. So this is the formula for associative property for subtraction. Okay. Instead of addition, I put a subtraction sign, and as it is, there is no change at all. Now let us see if associative property is valid for subtraction. Clear? Okay. Now, according to the formula, I have taken some integers. As I am dealing with integers, and I am still not dealing yet with rational numbers, first I am taking for integers, right? So let A is equal to 1, B is equal to 2, and C is equal to 3. Okay, so according to the formula, A minus B minus C is equal to A minus B minus C. So therefore, A minus B minus C is equal to A minus B minus C is the formula, right? Now, what is A? A is 1. 1 minus, what is B? 2. Put the bracket, write 2. Minus as it is, what is C? 3. Is equal to, again open brackets, what is A? 1. Minus as it is, what is B? 2. Minus as it is, what is C? 3. Correct? Now, 1 as it is, according to bracket of division, multiplication, addition and subtraction. What must? First I have to solve what? Brackets, right? So first I have to solve the brackets, keep the extra number as it is. So 1 minus, what is 2 minus 3 children? 2 minus 3 is nothing but minus 1. Why? Because plus 2 and minus 3. Plus and minus, you have to subtract and put the greater number sign. Right? So what is 3 minus 2? 3 minus 2 is 1. And plus 2, which is the greater sign? Greater number is 3. And it has a negative sign. So my answer is minus 1. So 1 as it is, minus of minus 1. Okay? Is equal to. What is 1 and minus 2? Plus and minus is again. Subtract and put the greater number sign. So plus 1 minus 2 is nothing but minus 1 minus 3 as it is. Now, 1 minus into minus is plus. So 1 plus 1 is equal to what? Minus and minus. Minus and minus is plus and put the subtraction sign. So 4 minus. Correct? So therefore I got minus 4. Why? Because same sign. Whenever I have same sign, I have to add and put the minus sign. When I have different signs, then I have to subtract and put the greater number sign. Correct? So, again, what is 1 plus 1? 1 plus 1 is nothing but 2 is equal to minus 4. Is that true? minus 4. Plus 2, in the number line we will think plus 2 and minus 4 are same. No, right? So plus 2 is not same as minus 4. So therefore, my left hand side is not equal to my right hand side. So therefore, what I get is the associative property for subtraction of integers is invalid. It's not valid, it is invalid. Okay, so what I did, I completely same formula like addition itself. Instead of putting an addition symbol, I have subtracted it, and when I subtracted, I came to know that my left hand side answer what I'm getting when I solve, and my right hand side the answer that I'm getting when I solve putting the formula is not same. It is not same. So therefore, as my left hand side is not same as my right hand side, associative property of integers for subtraction is invalid. Okay? Okay class. Now we will be studying completely about associative property in terms of integers for multiplication. See children, I have not yet come for rational numbers. Now I am just teaching about the integers. Alright. Now when I talk about associative property for multiplication. Before I go to multiplication, what we have studied associative property for addition. We have studied associative property for multiplication. When I studied associative property for addition, what was my formula? Formula was A plus B plus C is equal to A plus B plus C. Where first two I would put, last two I would put first bracket, and then here I put one more bracket, correct? So addition. Now subtraction was same. A minus B minus C is equal to A minus B minus C. Again for second and third, again for first and second. See what I did? Nothing. I just changed the signs. Similarly for my multiplication. If I am dealing with multiplication, same thing. A into B into C is equal to A into B into C. See, A into B into C is equal to A into B into C. Now where I put the bracket? I put for last two, and here I put for first two. Always remember my brackets I put for last two, and is equal to, after is equal to I put for the first two. Okay, so therefore I have taken some three integers. A is equal to 2, B is equal to 3, and C is equal to minus 2. Okay, so therefore, according to the formula of associative property for multiplication, instead of A, I put what? 2. 2 into, what is B? B is 3 into, what is C? C is minus 2, right? Where I have to put the bracket? B into C. So which is B? 3 is B and minus 2 is C. I put the bracket is equal to, open bracket, what is A? A is 2 into, what is B? B is 3 into, as it is, what is C? C is minus 2. Clear? So, first according to the God mass, what I have to do? I have to solve my brackets, correct? So, write 2 as it is, multiplied by 3 into minus 2 is what? Minus 6. 3 2s are 6, and put the minus sign. Why minus sign? First I will multiply. Whenever any numbers are given to you, like a huge set of numbers, like suppose 2, 3, 4, I have to multiply them, okay? And suppose I have minus 3 here. Okay, so what I will do is 2 into minus 3 into plus 4, correct? First I solve these two numbers. Now, plus into minus is minus. 2 3s are 6, correct? Now, minus into plus is, now I have to solve these both, correct? So, minus into plus is minus. 6 4s are 6 1s are 6, 6 2s are 12, 6 3s are 18, 6 4s are 24. So, minus 24. Got it? Similarly, now I am solving this. I get 2 as it is, and I am solving my brackets first. So plus into minus is minus. 3 2s are 6 is equal to, again solve the brackets. 3 2s are 6 into minus 2. Okay, so 2, okay, plus 2. 2 into minus 6 is what? 6 2s are 12. So minus 12 is equal to 6 2s are 12. As it is, put the minus sign. So therefore, my left hand side is same as my right hand side. So therefore, associative property of multiplication for integers is valid. Hence the proof. Clear? So what I did is, first the formula is A into B into C is equal to A into B into C. Right? So instead of, I have taken A, B, C some numbers and I have multiplied this. Okay, right? A is what? 2. So 2 into B is what? 3. And C is minus 2. So I have put this, substituted this in this formula. Then first I have to solve my brackets. So 3 2s are 6. Plus into minus, minus 6. So 2 into 6 is 12. Plus into minus is minus 12. Clear? Is equal to 3 2s are 6 into minus 2 as it is. Again 6 2s are 12 minus. So my left hand side is same as my right hand side. So therefore, associative property for multiplication of integers is valid. Clear? Okay children. Now let us start again the associative property for division. Okay, now similarly, first we studied associative property for addition, associative property for subtraction, associative property for multiplication, and now we are going to study associative property for division. In terms of what? Not yet rational numbers, we are still dealing with integers. Alright, okay. So first, let any B and C be any three integers. Then the formula for associative property of division is just same like addition and subtraction and multiplication. So for division it is A divided by B divided by C is equal to A divided by B divided by C. Okay, first last two numbers I put a bracket in my LHS is equal to first two brackets, first two numbers I put a bracket in my RHS. Alright, now let me start. A is what? I have taken 2, B is 3 and C is 5. Okay, so A is what? According to the formula, 2 divided by, what is B? B is 3. 3 divided by 5 is equal to, what is A? 2 divided by 3 divided by 5. Let me check if it is true. Now we say 2 divided by 3 divided by 5. First I'll keep, because this is out of bracket, I'll keep this as it is. First I'll solve my brackets. 3 divided by 5 is nothing but what? 3 by 5. Correct? Is equal to 2 divided by 3 divided by 5. This is what is given. Correct? Now, what I will do? 2 divided by 3 divided by 5. Now, 2 is nothing but what? 2 by 1. Correct? 2 by 1, when I divide this by 3 by 5 is equal to what? 2 by 3 divided by 5 by 1. If nothing is there in my denominator, it is always assumed to be 1. Now, when I have to divide any two fractions or rational numbers, the second fraction will become its reciprocal. Correct? Now, what will happen when I am dividing one fraction with the other fraction? First fraction will be as it is, that is 2 by 1. Okay? Division will become multiplication. 3 by 5 will become its reciprocal. That is ulta. 5 by 3. Clear? That means what? When I am dividing any two rational numbers or two fractions, first fraction I'll write as it is, division will become multiplication, and the second fraction will become its reciprocal. Alright children? Yes. So is equal to 2 by 3 as it is, division will become what? Multiplication. 5 by 1 will become 1 by 5. Now let us see. 2 5s are 10 divided by 3 1s are 3. Correct? Is equal to, oh, you can't see here, right? I'll just do it there. Yeah. So I have got up to 2 by 1 into 5 by 3 is equal to 2 by 3 into 1 by 5. Clear? Now what I'll do is, if I have to multiply any two fractions, directly multiply numerator with numerator and denominator with denominator. So therefore, 2 5s are 10 divided by 3 1s are 3 is equal to 2 1s are 2, 5 3s are 15. Do you think 10 by 3 is same as 2 by 15? Impossible. Correct? So my left hand side is not same as my right hand side. So it is invalid. Associative property for subtraction is invalid. Associative property for division is also invalid. Clear, children? So therefore we conclude by saying associative property is only valid for addition and multiplication, but associative property is not valid for division and subtraction. Clear? I hope this concept is clear for integers.